Today I am going to be discussing with some things regarding the classical and quantum mechanics, and this is the most important thing to know about the failure of classical mechanics and what point classical mechanics is failed and what is the difference between the quantum and classical mechanics. And many students don't know about the classical and quantum mechanics. We all are studying classical mechanics as a different branch of physics and quantum as a different branch of the physics. We will study separately. This we will study separately and this one we will study separately. But not like that. There is a relation between the classical and quantum mechanics. If you got that relation, then you will going to understand that each and everything about you can relate these classical mechanics with the quantum mechanics. And one more guys, without classical mechanics there is no quantum mechanics, because whatever our scientists were given a data about the quantum mechanics, it is all based on the classical mechanics. You can see God is not so cruel. Our God is not so cruel. Why I am telling this line? Because everything is connected with each other and there is no something new things. See, if you learn the classical mechanics, you can able to learn the quantum mechanics. If you learn the quantum mechanics, you can able to relate the quantum mechanics with the nanomaterials, electronics, like this. This is the basic fundamental. So God is not so cruel. God is given a very simple physics to us. God is very good because I believe in the God. Even though I am a physics student, but I trust in the God because God is not so cruel. God given a very beautiful physics to us. He given a very such a nice physics. He made us simple to us. He made it very simple. Because whatever we had learned in the quantum physics, we can easily relate to the classical physics also. Whatever we learned in the classical physics, we can easily relate to the quantum physics also. See guys, I will tell about the one thing about the classical and quantum mechanics. See, this is the starting point, this is the end point. This is the starting point, this is the end point. This is the starting point and this is the end point. See, our classical physics is coming in a reverse way. What? It is coming in the end point to the starting point. Actually, our quantum physics is coming in a right way. That is starting point to the end point. What I am telling to, I think you are not understanding about these things. I will tell about this in another way. What should I tell? See, in classical physics, they started to study with heavy objects like mass like a sun, heavy masses like a sun, galaxies, Milky Ways. These all are it's a simply macroscopic world, but in our quantum physics it is a microscopic particles. There is particles and how the force between the particles. But in our classical physics days, they went forward. They had went forward already because they only study about the bigger things. But see guys, I give another one definition and another one important things about these two. In classical physics, energy is different. See, actually day-to-day life energy is same. But one thing is we have to remember, in classical physics, energy is nothing but it is mainly depend upon position and momentum. Energy is mainly depend upon position and momentum. If momentum is there, energy is there. See, position. Why we need to consider the position and momentum only? Why we should not consider acceleration? See, this is the position and momentum are the fundamental things. See, with the help of position and momentum, we can able to calculate the energy. But in classical mechanics, what they had told, energy is nothing but simply, yes, energy is depend upon time. Energy is nothing but a rate of to do work. Yes, you can accept these arguments. But what happens in quantum mechanics? That energy becomes will going to be deal with energy in a different manner. Yes, they are also correct. Here also correct. But in quantum mechanics, energy takes a different places, and energy is variable in this one. You can relate the energy with the wave nature also. You can relate the energy with the particle nature also. We can relate with the energy in a different way in our class, in our quantum mechanics. But in classical mechanics, energy is always in the same manner. See, one more thing I'll give you an example. See guys, whatever I am doing this one job, this is simply a discussion. We want to learn that. We want to understand the point. What is the main point between the classical and quantum mechanics? See, in both cases are same. In classical mechanics also Hamiltonian will come. In our quantum mechanics also Hamiltonian is there. But see guys, in classical mechanics also Hamiltonian is nothing but a sum of kinetic energy plus potential energy. In quantum mechanics also Hamiltonian is nothing but a sum of kinetic energy plus potential energy. In both cases Hamiltonian is there. See guys, with the help of quantum mechanics, it is this quantum mechanics which is nothing but we are going to be deal with the smaller particles. Actually we can say that it is the modern physics, but according to me it is only I think quantum mechanics is, yes, it is developed recently. You are saying classical and modern one, okay, but if you saw between those things, I think this one is came to first in our mind, because we go in the right way in quantum physics. In classical physics, what you say that every particles have a momentum and momentum and position. We can able to find the position and momentum of anything. You can able to get that, yes, and this is the position of this one and movement of this body is mass into velocity. So you can able to find it. This is the classical physics. But in quantum physics, you can't able to predict. You can't able to tell that a momentum and position at a time. Why? Yes, in classical physics is also right. Quantum physics is also right, but in their ways. In quantum physics, what our scientists told that a particle is relatively, its velocity relatively near to the speed of light. Keep in mind this. So, due to the speed of light, there is the time variation is there. So that is nothing but Lorentz transformation. Galilean transformation will come first. Lorentz will come then our great scientist Einstein will come last. So that is the one beautiful world is there. With the help of, we can go into deal with the many problems. With the help of that one, our scientist, our great ISRO scientists are doing something else in other galaxies, other planets. We can judge the movement of the other planets. We can tell what we can able to predict the time of the other planets. We can able to predict on which velocity you will go. You can able to put a rocket into we can put a satellite into the other planets with the help of quantum physics. See, quantum physics is actually a study of smaller particles, but you can apply to the classical mechanics. See, with the help of quantum mechanics, we can able to go to the moon like this. There is a relation between the quantum and classical physics. See, I wish to. This video is not only for the students or BSc students or upcoming physics students. This video for the every physics lovers, every particular science lovers. I need a more information from you also, guys. That point, that turning point of the quantum and classical mechanics, and a main turning point I need to understand from you also, guys. I am doing a more study. I'm reading more theories of the classical and quantum mechanics. Even I am thinking about in which year that scientist came, in which year, and many things. There is a complicated in between the classical and quantum mechanics, and some scientists came in quantum mechanics. Even there is some scientists that came in the classical mechanics at a time. There is not like that. After classical mechanics, only quantum mechanics is came. Not this is not like that. There is some scientists are there before end of the classical mechanics. There is already quantum mechanics begins, I think. Yes. So it is not like in a particular after classical quantum is came. It's not like that. Everyone scientist is doing their jobs in a particular way. Actually, is my point of view is quantum is the first physics. Classical is the next physics. We are by using the quantum physics, we are applying in the classical physics. So in our upcoming videos, I am going to be discussing with the more detailed manner in this topic only. Thank you, guys.